Bonjour. Hello, everyone. My name is David Asher, and I'm going to be making a presentation today on natural cheesemaking and the use of natural starter cultures in commercial cheese production. Now, I want to give a little introduction to myself before we begin. I'm a natural cheesemaker, and I'll explain what that means in a little bit. Um, I make cheese according to traditional techniques, according to ancient wisdom, according to traditions of fermentation, similar to that of sourdough bread baking, natural wine making, and vegetable fermentation. And I practice a very different style of cheesemaking than what is often practiced in commercial cheese production, especially in North America today. And I'm very grateful for Maryse and the team at the Centre d'Expertise de Fromagère de Québec for giving me an opportunity to address the Quebecois cheesemaking community and to introduce or talk about some of these ideas that can help cheesemakers realize improvements and advantages in their cheese production in their dairies. Now, I have to say before I begin, I just want to give a little shout out to the Quebecois cheesemakers who have inspired me so much. I am a Canadian cheesemaker. I'm based in British Columbia, though I travel widely, as I'll explain. But my cheese aesthetic was very much inspired by the Quebecois artisanal cheese community. And I had my first taste of real cheese when I lived in Montreal many years ago. Cheeses like Au Pied de Vent and cheeses from Au Grès des Champs and other traditional raw milk cheeses really inspired my taste and aspiration to become a cheesemaker when I eventually became a farmer many years later. And when I first had access to raw milk, when I first started farming and keeping goats and receiving their milk, I felt inspired to transform that milk into to cheese, in large part because of the experiences I've had and the taste that I've had and the understanding that I had of sort of milk's destiny. And very much milk is destined to transform into its cheese. But when I first started out on my cheese making journey, I, I felt dismayed at the standard way in which cheese was transformed from its milk. I felt as though something was missing, and I couldn't really follow the standard instructions that were given out by the typical cheesemaking books, or that I received at the various apprenticeships that I did with cheesemakers across Canada. I felt that an important connection was missing. And I didn't want to have to pasteurize my milk according to the instructions, or add in freeze-dried starter cultures like these, which I understand many of you use, in order to create the conditions that allowed my milk to transform into its cheese. I felt that something important was missing when cheesemakers use these. I felt inclined to do things a little differently, much the same way that I made my sourdough bread, much the same way that I made my natural wine, much the same way that I fermented my vegetables. And I'm not just a cheesemaker; I'm also an organic farmer. I practice very much a full circle philosophy in my agriculture, keeping seeds from one season to the next, fermenting my vegetables to preserve them. And when I made the first batch of cheese with my very first milk from my goats, I felt inclined to transform the milk in a very similar way. And I just decided to ferment it, to handle my milk the same way I handled my sourdough, the same way I made my natural wine. And I threw in a culture called kefir, which we'll talk about a little later on, that contains a broad diversity of beneficial microorganisms that help my milk evolve into cheese in the most extraordinary way. And the very first batch of cheese that I made was as delicious as any of the cheeses that I ate in Quebec. And I felt inclined to experiment and play more with these traditional techniques that seem to make cheese in the right way. And I started teaching cheese making classes as well, sharing my discoveries about making cheese in a traditional way with others who were interested in understanding how to work with raw milk and how to use these natural starter cultures. And the more I taught, the more students would ask, are there any resources that you could point me to help me understand cheesemaking from this more traditional perspective? And unfortunately, there wasn't really a book that I could recommend. The only book I could really advise people take a look at was a book about fermentation by an author named Sandor Katz. His books are the Wild Fermentation and the Art of Fermentation, which have been translated into French, I believe. And his books were definitely a guiding light for me, understanding how milk can transform into cheese in its best possible way using these traditional techniques. And so, uh, uh, with the encouragement of my students, I decided to write a book about cheesemaking using these traditional perspectives, addressing the issues of natural fermentation, along with the use of raw milk and other important issues. This is the book. It's called The Art of Natural Cheesemaking. I published it back in 2015, almost 10 years or so ago. The book has been translated into French. I prefer the French version. This is the L'Art de faire son fromage. Offers cheesemakers much of what they need to understand in order to transform milk and cheese into cheese in its most natural way, using these traditional starter cultures that we're going to talk about in this class. Since my book was published about 10 years or so ago, I've been on a near constant cheese tour, giving cheesemaking classes like these to cheesemakers all around the world. I found that my ideas have resonated with cheesemakers in all sorts of places I never would have expected. And I found it very hard to say no to the wonderful invitations I received to teach cheesemaking across Europe and North America and elsewhere. In the meantime, I've decided to put farming on hold. I had to say goodbye to my goats. I had to say goodbye to my gardens. But nowadays, I'm focused entirely on cheese education and outreach, helping people understand the reasons why we need to transform milk into cheese in a more natural way, and helping people grasp the techniques that are necessary in order to make this most wonderful transformation happen. Now, I've written a second book, and it's due to be out in just a few months, actually. This upcoming book is going to be titled Milk into Cheese. And the first book that I wrote is sort of an introduction to the ideas of natural cheesemaking. And this next book is going to be a much more in-depth exploration of these natural ideas and a much more sort of global perspective on the traditions of cheesemaking. So I guess we can begin our presentation now. I make cheese naturally. And I have here one of my cheeses that I've made in a more natural way. This is a sort of Saint Marcelin style of cheese that I've made with some cow's milk that I've fermented in a very traditional way. That I've made according to the principles and philosophies of natural cheesemaking, including the use of a natural starter culture that's helped the cheese ferment in its best way, and even develop this beautiful wrinkly rind that you see on the surface that's typical of cheeses that are made with a traditional ferment. And this natural coat of Geotrichum candidum is a sort of evolution of these natural communities of microorganisms that are a part of natural cheesemaking. Anyhow, this cheese embodies the four underlying philosophies of natural cheesemaking. These four philosophies are that cheese is agricultural, cheese is cultural, cheese is biological, and cheese is microbiological. And I want to briefly introduce these four ideas, but then focus on the final one, that cheese is a microbiological phenomenon. So cheese is very much a cultural phenomenon. And the way that it's made influences the way that it evolves. And the way that it's made is influenced by the culture in which the cheese is made. And a cheese tastes very much of the culture behind its transformation from milk into cheese. And there's many different ways to look at this. Cheese can be influenced by the religious culture, by the economic culture, by the industrial agriculture, or even by the material culture of a society, for example. And the cheeses that I have over here, this sort of style of farmhouse cheese that's originally from France, is very much influenced by the traditions and the cultures of small-scale agriculture in the south of France, where this style of cheese is very well known and appreciated. And if this cheese is made as a part of that agriculture, it follows through with this beautiful story and evolves in its most wonderful way and creates extraordinary flavors that are a part of that culture, a sort of continuity of that culture. Whereas if a cheese is made in an industrial culture, an industrial agriculture, the cheese very much tastes of that industrial interventions that are involved in milk transformation into cheese. And you can't make a cheese that's made in an industrial culture taste like a cheese of a more traditional culture, because the right conditions aren't created with the way that milk is handled. And if you want to create a cheese that tastes of a certain place or a certain culture, you have to recreate that culture. And even if you're making cheese in a commercial setting, if you sort of recreate the conditions in your cheese making that are the traditional farmhouse productions of like traditional French goat's cheeses or cow's milk cheeses like these, your cheeses will taste of the traditional flavors. They'll taste of the traditional cheeses of France if they're made according to the philosophies of traditional cheesemaking in France. Now, cheese is also agricultural. It's very important to understand this. Cheese is often considered an industrial product today, something made in a factory. But this is a bit of a confusion. Cheese should be understood as an agricultural product. I believe cheese should be reconnected with its agriculture. And the more cheese is connected with its agriculture, the better the cheese will be. And the more of a separation there is between cheese and its animal agriculture, the worse the cheese will become. Now, in the most traditional circumstances of cheese making, cheese is made with milk right from the udder, still warm. And when milk is taken right from the animal and goes directly into the cheese making vat, the cheese evolves in its most exalted way, and the milk isn't damaged or destroyed by the technologies of preservation like refrigeration. And the cheese evolves in its most flavorful way. Um, uh, these days, it's not very common for cheesemakers to connect their agriculture with their cheesemaking. We often put a wall in between cheese and its agriculture, a literal wall between the dairy and the cheesemaking operation, and nothing can pass between the two other than the milk. Um, but the more of a separation, the more of a wall there is between cheese and its agriculture, the worse the cheese will become. And in a typical dairy in North America today, I include Quebec in this, most cheesemakers will not use the milk directly from the udder still warm, but instead they'll chill the milk, put it into the bulk milk tank, keep it for 2 days, and mix that milk with subsequent milkings, 3 or 4 milkings total, into that bulk milk tank. Then the agent from the Dairy Farmers of Canada will take their milk from the bulk milk tank and put it into their cheesemaking vat, and the cheesemakers will then work with that milk. That's a mixture of milks from 4 milkings that's up to 2 days old. And when cheese is made with a milk like that, the cheese doesn't. The cheese is separated from its agriculture, and the cheese needs more interventions in order to evolve in its best way. And it's quite possible that milk will need to be pasteurized as a result of the long refrigeration that encourages unwanted microbes to grow. It's quite possible that milk will need to have, because it's been pasteurized, that you'll have to add calcium back to that milk in order to undo some of the damage that's done by the pasteurization. And the more the separation grows, the more the quality of the cheese declines. And the more we reconnect the cheese with its agriculture, the better the cheese gets. And if we use milk warm from the udder, we avoid unwanted microorganisms that get a chance to grow in milk when it's refrigerated. We avoid the degradations that come about from the regular mixing of the milk in the bulk milk tank and the oxidations and rancidifications of milk fat that result from that. If we use a natural rennet, for example, as we'll describe, from the animals themselves, and we use a natural starter culture that evolves from the milk in its most natural way, as we'll discuss, this cheese will evolve in its most extraordinary way and have its best possible flavor. So it's very important that we reconnect cheesemaking with its agriculture. And it's something that's unfortunately very challenging to do in Canada. As we'll talk about, and probably we'll have some questions about this after the session. But here in Canada, my cheesemaking style is essentially illegal because of various controls and restrictions on the use of fresh raw milk. I understand that in Quebec, there are more legalities, more capacities for cheesemakers to work with fresh, warm, raw milk. And it is possible in Quebec, perhaps more than anywhere else in North America, for cheesemakers to make this reconnection between their farming and their cheesemaking. So, moving on, it's important to understand that cheese is a biological phenomenon. We tend to think of cheese as a human invention, but everything we do in cheese is actually actually has a natural precedent, a sort of biological precedent. And the way milk transforms into its cheese is part of the way milk is digested by infants that drink their mother's milk. And not everybody realizes, not even all cheesemakers, but when a young animal drinks its mother's milk, it transforms its mother's milk into cheese inside its belly in order to get a better grasp on that milk, in order to properly digest it and churn it and break it down the way it needs to in order to get nutrition and nourishment from that mother's milk. And just about every aspect of cheese's evolution is actually related to the way in which milk is digested inside the stomach of a young animal that's drinking its mother's milk, including cheeses like these, which are soft lactic styles of cheese. This is a Saint Marcelin. It's long fermented that has a very low pH. And the cheese has a very soft and creamy texture, in large part because of the way milk is digested inside a young ruminant's stomach. That causes the milk to break down into a soft, creamy paste. And this phenomenon, this biological phenomenon, makes this style of cheese happen in the dairy. And finally, the final thing I want to say about natural cheesemaking is that natural cheesemaking is a microbiological phenomenon. And milk has the capacity to evolve and ferment in its own way without having to use freeze-dried starter cultures, because milk is a microbiologically rich substance. And the microbes are a part of that milk. They're meant to be in that milk. And if cheesemakers handle their milk in the right way, the milk will evolve its own microbial community that makes cheesemaking extremely safe and negates the need for cheesemakers to have to purchase freeze-dried starter cultures like these. So natural cheesemaking works with just about every style of cheese. And you can make camemberts, you can make blue cheese, you can make wash drying cheeses, you can make alpine styles, you can make lactic cheeses, you can make kefir and yogurts, all with natural starter cultures, all with natural rennet, in much the same way that traditional cheesemakers have historically. And all styles of cheese that we know and love today were all evolved before the use of freeze-dried starter cultures, before the use of pasteurization, before the use of commercial rennet. Cheesemakers worked with materials that they had from their animals, that they had from their farm, and the cheeses evolved in their best way without interventions. And the way a camembert evolves and develops this beautiful white rind is a sort of continuity of the traditions and the way in which cheesemakers handle their cheeses in Normandy that encourages cheeses to evolve this extraordinary, beautiful microbiology. Milk has the capacity to ferment in this most extraordinary way. And we don't typically think about milk having the capacity to ferment itself. This isn't something that is generally discussed in dairying today, but it's something that cheesemakers are starting to talk about more and more. The science of the microbiome that's been explored in the past decade or so has cast light on an entity known as the microbiome. It turns out that milk from a mother is one of the most important contributors of this beneficial microbiome to the young infant, cows, goats, sheep, and human to drink their mother's milk. And milk itself contains hundreds of different species of beneficial microorganisms that are a part of that milk, that are meant to be in that milk, and that cause milk to ferment in the guts of young milk drinking mammals. And cheesemakers don't have to purchase freeze-dried starter cultures in order to make their cheese. Just about every single microbe that a cheesemaker might need is present in raw milk, as part of the way in which that milk is digested in young animals' stomachs. Cheesemakers can cultivate this community of beneficial microorganisms from their milk in similar ways that a natural bread baker will cultivate the communities of beneficial microorganisms that are in their flours that will cause their breads to rise. And milk, it turns out, is actually meant to ferment. These microorganisms that are in it are meant to digest the lactose sugars that are present in the milk. They're meant to transform them into lactic acid and glucose and other sugars that make the milk more digestible. These microorganisms also help establish a very important sort of immune function within the young milk drinking animals that keeps unwanted microorganisms from growing inside that gut. And these microorganisms also seem to modulate and play very important roles within the infant's well-being and state of mind, and on and on and on. These microbes are a part of the milk and should be recognized as a part of the milk, just like the fat, the protein, the sugar, the warmth of the milk, and the microbes of the milk. These should be understood as being a part of the milk itself. But we often see microbes in milk as a sign of contamination. We strive as dairy farmers to reduce the microbial loads in our milk as much as possible in order to keep the milk from fermenting, in order to keep the milk as milk, in order to get a better price if we're dairy farmers selling our milk. We get reductions in the sale of our milk if I have high microbial counts. These microbes that are present in milk are extraordinarily diverse. And they do include some, unwanted microorganisms like coliforms. But in general, the microbial community of milk is beneficial and contains these extraordinarily diverse species of beneficial bacteria, fungi, and yeast that are a part of that milk, that are meant to be in that milk, and that consume the sugars that are provided by the milk. And um, good practices of milk handling and fermentation actually encourage this community of microorganisms, the beneficial milk microorganisms, to outcompete the unwanted microorganisms in the milk. And when you handle milk in the right way, according to these natural techniques, this good fermentation that's encouraged actually discourages unwanted microbes like coliforms, which are opportunistic microorganisms, from developing in the milk. Um, and uh, uh, it seems as though most milks around the world have the same sort of microbiological community. They all contain an extraordinarily diverse community of beneficial microorganisms that can all develop their own starter culture more or less the same way anywhere in the world. And as a cheesemaker, you can't really work with milk and its microbes without adding a starter culture. Milk on its own, especially the way that it's prepared in a dairy today, is too clean and doesn't ferment properly. And milk doesn't have the community of microorganisms that it needs to ferment in the right way. Cheesemakers need to add a starter culture to their milk in order for the milk to ferment and protect itself from the growth of unwanted microorganisms. And there are essentially 4 ways that a natural cheesemaker can do this. A cheesemaker can use natural materials like wood or clay that hold on to microbes from batch to batch. They can use whey saved from one day's cheesemaking to the next in order to seed the beneficial microorganisms that cause milk to ferment in its best way. They can use a fermented milk starter culture. Sometimes I call this a clabber culture. It's an Irish word for the fermented milk. Or they can use a kefir culture, as we'll discuss, to carry forward this important fermentation. And in a dairy today, which is generally too clean, in which the milk is milked in sterilized milking machines, the milk needs to have a very low microbial count in order to follow through with the industrial system. But nevertheless, cheesemakers can introduce a strong community of beneficial microorganisms that's developed from that milk from their farm that can allow their cheese to evolve in its best possible way. And these are the 4 ways essentially of doing so. And I'm going to go through these different techniques now. So I'm going to talk about natural materials for a moment. Originally, cheesemakers didn't know that microbes were involved in the transformation of their milk into cheese. But by making cheese day after day after day in the same natural materials, for example, making cheese day after day after day in a clay pot or in a wooden vat, like the gerle of the Auvergne, held on to beneficial microorganisms from the milk from one day's cheesemaking to the next. And these natural materials that can't be cleaned out, and indeed aren't cleaned out by cheesemakers that use them, these natural materials hold on to the microorganisms, most beneficial microorganisms of the milk, that induce a beneficial fermentation very quickly that keeps unwanted microbes like coliforms from growing. And when that gerle is used day after day for cheesemaking, the cheesemaker doesn't even have to think about adding a starter culture to their milk, because the wooden vat becomes the starter culture. And when the vat is used day after day after day, that culture is fed, much like a levain, much like a sourdough starter culture, and allows the most beneficial microorganisms to grow in that milk, that allows the cheese to be made in its best possible way. And cheesemakers in the Auvergne today who use the gerle make cheese in their vats actually twice a day, with milk from every day's milk, with milk from every milking. And this regular use of the wooden vat encourages the best microbial community of that milk to evolve and keeps that cheese as safe as possible. This is a picture of the traditional gerle from the Auvergne. It's made of chestnut wood, and the cheesemakers in the Auvergne today are still permitted to use these natural materials in their dairy, in part because they've proven with microbiological analyses that the cheeses that they make inside these wooden vats are actually quite safe, indeed perhaps safer than cheeses made in stainless steel with the use of freeze-dried starter cultures. And this is the precedent of natural fermentation that has led to more or less all the styles of cheese that we know and love today. Most styles of cheese evolved from the traditional use of wood, in which cheesemakers didn't know that fermentation was happening. But by making the cheese regularly in their wooden cheesemaking vats, the culture was carried forward from one day's cheese to the next. And this is the tradition, for example, of cheddar here in North America, which is actually an evolution of the traditional cheese named Cantal, which was historically made in the gerle in the Auvergne. When cheese is made in wood, the wood holds on to the culture from one day's cheese to the next. But when cheese is made in a copper kettle, when cheese is made in that more alpine style where the cheese is cooked in the copper kettle has to be washed out after each day's cheese make, because the copper degrades, it rusts and develops verdigris, which is quite toxic, if the copper is left in an acidic environment, if the whey is left to ferment in the vat. And so cheesemakers historically cleaned out and to this day, cleaned out their copper kettles, and then introduced whey from the previous batch of cheese as a starter culture for the next batch. And the traditions of using whey as a starter culture for cheesemaking are understood to be ancient. They probably go back to Roman times. And the whey starter culture can be easily saved from one day's cheesemaking and used for the following day's cheese. Day after day after day, this culture can be fed and rejuvenated with by making a batch of cheese, and then by saving the whey and leaving it to ferment overnight to the following day, the cheesemakers create the right conditions that encourage the milk's best microbes to grow and allow their cheeses to ferment in the best ways. And that there's many cheeses across Europe that are still made today with whey starter cultures. Most of the mountain cheeses in Switzerland and France and Italy are made with a whey starter culture that's understood to be safe and effective. Cheeses like Parmigiano Reggiano have to be made with a whey starter culture in order to receive their DOP status. It's sort of understood that whey cultures work for cheese, that they're very safe, they're very effective, and they can be used in both a raw milk cheesemaking and a pasteurized milk cheesemaking. They cultivate this extraordinary community of milk fermenting microorganisms all on their own. But the question arises, if it takes whey to make whey, where does that whey starter culture come from? You can create a whey starter culture essentially by leaving milk to ferment. And if you take raw milk, this doesn't work with pasteurized milk. If you take raw milk and leave it to ferment in a jar, fresh raw milk, preferably from the udder, still warm and unrefrigerated, is the best. If you take some raw milk and leave it in a jar and leave it at room temperature, temperatures around 20 to 30 degrees. If you leave it out for 2 to 3 days, this milk will spontaneously ferment into fermented milk. I call it clabber. And that first fermentation doesn't usually go very well because the milk is too clean, and there aren't that many good milk fermenting microorganisms in that milk because it comes from a modern dairy. The milk wasn't milked into a wooden bucket. It was taken from the animal in a fairly sterile way. But the milk will still ferment. It'll take 2 or 3 days though, and that's kind of long. It's not safe necessarily. But once this milk curdles, it'll turn into something like this. This is a fermented milk. And this fermented milk can then be backslopped. It can be put into a clean jar. And the fermentation will then be initiated much quicker. And even though this first ferment isn't necessarily the best quality, when the microorganisms in the milk have the capacity to overcome that. And when we recycle this fermentation, when we do a transplant, as they say in French, le repiquage, in English I'll say backslop. When they backslop this culture from one batch to the next, you take a spoonful of this and you put it in a jar and you feed it fresh milk. If you put a little bit of that next batch into some fresh milk again, again fresh from the udder, still warm preferably, when you plant the seed, that milk ferments much better. And instead of it taking 48 hours, 72 hours for that milk to curdle and sour, when you plant the seed of the previous batch in the milk, the fermentation happens in 12 or so hours. And this will be, this is fresh milk fed with a little bit of the previous batch of lait fermenté, fermented milk. And within 12 hours, this milk will ferment into more clabber, like this. And I'll be able to do that again. And this starter culture can be kept by regularly feeding it fresh milk day after day after day. You can keep this culture for your entire cheesemaking career if you want, by regularly feeding it fresh milk on a daily basis, or even keeping the culture in the refrigerator for up to a week, or freezing it for a couple of months. It's best to feed it every day to keep the cultures in their best form. But these cultures take a little bit of care and attention in order to keep them working their best. But as long as you give them the care and attention, the cultures will always perform their best. And they'll actually outperform these freeze-dried starter cultures because they're very stable and very strong and very microbiologically diverse. They don't die off due to bacteriophage, for example. They don't need sterile conditions in order to thrive. They ferment raw milk actually very well. And you can actually develop a culture specific to goat's milk or sheep's milk if you have those milks by re-fermenting, cow's milk, goat's milk, or sheep's milk. These cultures don't have an expiry date. They more or less last forever as long as they're cared for forever. And they provide just about all the microorganisms that more or less any cheesemaker might need for all of their cheeses. And cultivating this culture at 20 degrees Celsius makes a mesophilic starter culture. But if you ferment this milk at 40 degrees, you get a thermophilic culture. You get a yogurt culture or a higher temperature milk fermenting culture that you can make alpine styles like comté with. And these starter cultures, these fermented milk cultures, can then be used as a starter to make a first batch of cheese that you can then save the whey from if you want to make a whey starter culture. And this is essentially how you make a whey starter culture. You more or less just leave milk to spontaneously ferment itself and then cultivate the community of beneficial milk fermenting microorganisms through backslop or transplanting. And in the natural wine community, folks refer to this as a pied de cuve, the bottom of the barrel. A little bit of the previous batch being used as a starter culture for the next actually initiates a beneficial fermentation. And the material itself, whether it's the grapes or the dough or the milk, contains the microorganisms that cause this fermentation to initiate. But it's best to do a cyclical fermentation and not just do a linear fermentation. And by transplanting the culture day after day after day, you cultivate milk's best microbes. Okay. Now, there's one final way of cultivating milk's community of beneficial microorganisms. We can move to the next slide. Kefir is the final way of cultivating milk's community of beneficial microorganisms. Kefir is a phenomenal community of beneficial microorganisms. Nobody knows where it comes from, but it exists, and it's something to be in awe of. It's this sort of living creature that lives in milk. And these are my kefir grains. And you put these little things into milk, and these little things, they ferment the milk into kefir. Then you can strain the kefir grains out of the kefir. You can use the kefir as a starter culture for making cheese. And then you can put the grains into more milk and make more kefir. And you can do this day after day after day, and the kefir grains will grow and thrive and ferment milk over and over and over again. And again, nobody really knows where kefir culture comes from, but the fact that they exist tells something important about milk. And to me, it's sort of proof that milk is meant to ferment. Cultures have been keeping kefir for millennia. Not many people are using it in cheese making today, but historically it may have played a very important role in milk's proper fermentation, because historically cultures would have understood the kefir as like a seed that you plant in milk that causes milk to ferment in its best way. And there's some archaeological evidence of kefir from China. A mummy was found named the Beauty of Shaowei, who was buried some 3,000 or 4,000 years ago. There's a picture of her right there. And she was preserved by the dry desert conditions in Western China. And she was laid to rest with these beautiful clothes and this gorgeous hat with a beautiful feather and this strange necklace that nobody could really explain. And about 10 years ago, some protein scientists studied these lumps that were on the necklace that were previously unexplainable. And they found protein signatures in the lumps that were the same as what you see in these kefir grains here. This Beauty of Shaowei was buried with kefir grains, which is astonishing to think about. This kefir that I'm keeping here today is sort of the same lineage as the kefir that this beautiful mummy was keeping and using, presumably to ferment her own milk. It's quite possible that people historically used kefir to ferment their milk all around the world. This Beauty of Shaowei, though she was found in China, she's actually understood to have a European heritage. Her DNA proved that she was from sort of the Caucasian region of Europe. And she was practicing a traditional agriculture, milking goats and sheep and making kefir. And probably this sort of form of fermenting milk made its way all around the world with the help of these original agricultural settlers who brought the technologies of goats and sheep and cheese making and kefir making to various corners of the world. And these early milk fermenters would have depended upon cultures like kefir to assure a proper fermentation, because these nomadic pastoralists didn't drink milk necessarily, but they transformed milk into cheese using traditional fermentation. And this cheese is what they lived off of, is what sustained them in the harsh climate of the Central Asian plateau. And many people in this part of the world still keep kefir and ferment their dairy in much the same way, transforming their milk into cheese with this form of traditional fermentation. So you can keep kefir and use it as a starter culture in making cheese. There's actually some Quebecois dairy producers that use it. Liberté, from what I understand, makes one style of kefir that uses traditional kefir grain. And my first taste of kefir 20 some odd years ago when I was living in Montreal actually came from a traditional kefir that was made with a kefir grain. Although I think they may have discontinued that batch because of their impressions of what consumers want. But the kefir that was made with the traditional kefir grain was extraordinary, and it sort of got me hooked on natural fermentation. And one taste of this made with traditional techniques, made with good milk and good fermentation, will get you hooked. Kefir makes you feel good. It's an extraordinary source of beneficial probiotics, but also a source of extraordinary diverse microorganisms for making cheese. And it contains beautiful yeasts that help cheeses grow gorgeous rinds, just like that cheese I showed you earlier today. This one here, the beautiful Geotrichum candidum develops just with the help of the microorganisms that are present in kefir. All right, so we can move on to the next idea. So, we understand that cheese can evolve in a natural way. There's many studies out there that show the safety and security of traditional techniques. There's much precedent. All cheese that we know and love today was created with natural techniques. So why are we so hesitant to use natural techniques in our dairies today? Well, there's a sort of fear about them. The modern technique of cheesemaking sort of implies that traditional techniques don't work. And when you learn to make cheese this way, this techniques of using this cheese force you to distrust your milk and to distrust its microorganisms. And it's hard to break that fear of milk and its microbes. But your milk has what it takes, and you can build confidence in your milk's ability to ferment itself. You can learn to use these natural starter cultures. They do work really well. And the more you have faith in these natural methods, the more they will work in your dairy. And the more you use them, the more you tend to these cultures and give them the love and affection that they need, the better these cultures will actually perform. And it's a matter of faith. And it also helps if other people are using these techniques around you. And I don't know in Quebec if anybody is currently using natural techniques as I describe them, but in many places of the world where natural techniques have become more commonplace, like in Uruguay and the Netherlands and Switzerland and Italy, all these places where I've taught and helped get the word out about natural cheesemaking, it helps that there's somebody on the ground in those countries that's a proponent of these natural techniques themselves. And it helps to show people that these natural techniques work in the cultural circumstances in which these cheesemakers are working. And there might be some challenges in Quebec for making cheese in a natural way, but there isn't necessarily anything that's illegal about using a starter culture like clabber or kefir in your cheesemaking. And it's just sort of in our heads. The culture of using this style of ferment can change. If we change our understanding and accept that milk can ferment in a different way, that milk is meant to ferment, that has microbes present in it that are meant to be there, we can trust that this will work. And the more cheesemakers use these natural methods, the more proof there will be that this technique works. And the safety and security can be tested, of course, of the starter culture and the cheeses made with them. And there's no reason to fear the communities of microorganisms that are present in here. Something you sometimes have to see for yourself. I encourage people to experiment and play with small batches in their dairies or at home in order to gain faith in these traditions. But it's something that will work even on a large commercial scale. Of course, remember, all styles of cheese evolved originally from these traditional technologies. And there's something very special and important about the way milk ferments that needs to be honored and appreciated. I hope you'll consider some of these ideas in your dairy. Natural cheese makes a big difference, both ecologically, economically, efficiently, and organoleptically. Cheeses made this way taste better, evolve better, and save a cheesemaker time and energy. And I highly recommend cheesemakers use these natural techniques. They really help bring a wholeness and completeness to a cheesemaking operation. Cheesemakers often don't like to have to buy these freeze-dried starter cultures, and you don't need to. Your milk provides all the microorganisms that it needs, and you can take ownership over one of these most important parts of milk's transformation into its cheese. So these natural techniques have come a long way. 10 years or so ago, nobody was talking at all about natural methods in cheesemaking. But in the last 10 years, cheesemakers around the world have started adopting these natural techniques and have started putting faith in milk and in their milk and its microorganisms. And this is something that can work for cheesemakers just about anywhere in the world. Milk has the capacity to develop its best community of beneficial microorganisms anywhere. not just in France and Italy and Switzerland and these original cheesemaking heartlands, but everywhere in the world where cows are kept. Milk has the capacity to ferment and develop the same community of beneficial microorganisms. Um, this is not something that's unique to Europe. This is something that's unique to milk, and all milk is capable of doing this. Um, um, as long as we uh, 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 do it, as long as we create the conditions that cause this to happen, this will happen. Um, but in letting go of it and giving control of the microorganisms of our milk to corporations like Danisco, who provide these cultures, as a subsidiary of Dow DuPont, one of the world's largest agrochemical companies. Um, in sourcing our rennet from companies like Christian Hansen in the Netherlands, sorry, in Denmark, that provide something like 80% of the world's rennet supply. We give up control of our cheesemaking to another entity, and we sort of lose a connection with the way in which our milk transforms. And milk transforms from a farmhouse product made in a natural way into something that's much more industrial. It depends on these ingredients from afar, and that unfortunately changes the way the cheese makes, and changes the way the cheese is made, and changes the way the cheese tastes. And if a cheesemaker is looking to really significantly improve their production and link up the philosophies of their agriculture with their cheesemaking practices, then natural techniques really are the way to go. And I'll end the presentation there. Thank you very much. And I hope you'll have success with natural techniques in your dairy. And please be in touch with me if you're interested in learning more. You can find out more in my natural cheesemaking classes that I offer both in person and online. And of course, you can email me. I'll send you my email in the course notes if you're interested in connecting. All right, thanks everyone, and enjoy the rest of the conference day.